What I might just, while I've got this here, I might just, I'll cut these fittings off, and I'll just do a quick diagnostic on some valves for you guys as well while we're here, if that's cool. So, I think if you've never been exposed to it before, it's just new. But yeah, I was going to say, like, once you get it, yeah, it's fine. And again, it's one of those. If you don't do it all the time, you might forget it. But it's very simple as far as knowing that with an AC system, you're always going to have one colour to one valve, and then there's a common. Doesn't matter what controller is out there, it's always the same. No matter where you are in the world, that's the same process. The only time it changes is decoder systems. Have you got decoder systems out here?
Yeah, a couple of decoder systems, yes.
Yep, so that's a different day. We'll do that. But decoders, I believe, are moving forward now. More and more commercial systems will move away from this side of things and go to decoder. And then Rainbird's new IVM system, which effectively is the coil is the decoder. So their new IVM is actually that solenoid valve, the solenoid coil, has a computer chipset in it. So at any point, yeah, it's got an address in it. So we're actually telling the controller, like, it might have, 1, 2, 3, 4, 5 on the side. And we say, well, station 1 is address 1, 2, 3, 4, 5, like a mobile number.
Oh, okay.
If that makes sense. And that's how decoder sort of works. And then we then go to station 2, and it might be 1, 2, 3, 4, 6, depending on how these come out.
You have to take that coil to the controller like you do with the decoder and program.
Yeah, so the Hunter decoder, if you've got Hunter decoder now, you would have had to put it into a programming port and tell it that it's Hunter's the only ones that do that.
Webmatic is the same thing.
Oh, do they? Okay, cool.
The two decoder systems that have got,
Yep.
Take the decoder back to the controller.
Yep.
Plug it into a decoder port.
Yeah, okay.
Program what.
Yeah. You can do it on the field if you've got a handheld programming device for $1,500 or whatever.
Yeah, it sounds like the investment.
Yeah, it should. Yeah. So whereas Rainbird tend to have, so Rainbird's valves, decoders have an address on them.
I like that, that makes sense.
Yep. And then their new IVM is no decoder. So it's like decoder, but they've taken, obviously, and the reason being was, and a big part of it, as you saw, we're doing all these wire joins, there's things that can go wrong here. So when you do a decoder, you've come from your field, which is a 2-wire only, it's only 2 wires. It talks to the decoder, you've got a wire from the 2-wire into the decoder, which is 2 joins, and then out of that decoder into your solenoid valve, which is another 2 joins. There's 4 potential failures there, whereas where the IVM, they've halved that because they've gone 2-wire straight into that. That talks to it. And then you can have diagnostics now with the new IVM that if it actually, you could have 70 valves out on a field and it will tell you valve 59 is red. And it will know that valve 59 is red, and then also, but valve 60, 61 following is all red as well. Now that for me tells me if everything 58 and forward is good, cool. I'm going to go out to between valve 58 and 59. Someone's done some root pruning or something like that and gone straight through cable. That's an easy find. And 90% of the time it is that simple. And it's the same technology they use on golf courses now, instead of having to try and find where there's voltage leaks and all this sort of stuff. So it's really, really handy. That's where we're seeing a lot more councils are starting to go into the IVM side of things now.
The Hunter will tell me that.
Correct.
Well, not exactly the same, but I mean the Hunter will tell me that there's a fault at 58.
Yep.
So you know that's your starting point. So they're going to be at 57, the wire join.
Yep.
At 57's
Yep.
failed. Wire join at 58's failed. Because then in 59, 60, 69
Correct.
will not work.
Yeah.
That's what the fault's going to be. Otherwise, it's going to be, if it's just one station that's coming up as a fault.
Yep.
Then with the Hunters, because they've got trouble with decoders,
Yep.
I know that probably my first port of call is the decoder at 58.
Yep.
Yeah, shit, and they always fail. So.
Yep, that's right. So you're spot on as far as you do get feedback. Where the IVM gives you a bit more is you get a higher range of diagnostics in there, so you can actually tell, and you can ping all your addresses, and you can set that up from a central control standpoint. At the end of a Friday, just go, I want to know how every coil's out there in the field, and then it'll give you a report of anything that's red, and you sort of go, oh, okay, well, I know, for sure valve 50, that's coming up red, that's not going to come on this weekend, but I'm okay with that because I can deal with that on Monday, but it's 40 degrees. We actually really need to go down and figure out why that is. So it's really handy. You can do that literally from your computer or on your phone and ping every coil out in your whole site and tell you what's going on. So,
like the other CPU ones that you can set up and send you a message anyway. So Saturday, it doesn't come on. So Sunday morning when I wake up, it says on my email.
Yep, that's right. So we can set up as many alarms and alerts that we want to see, so we can have it where, especially if we put flow sensors at the start of the systems, they do what's called seek and self, which is search and eliminate low flow or excessive flow situations, and that's a case of us being able to say, well, a station's supposed to be doing 50 litres a minute, and all of a sudden that station's turned on, it's doing 150 litres a minute. It's going to shut that station off because it's reached a threshold point that we said any more than 30% over, I want to turn off. Turns the station off, moves to the next station, and then if it's all good, then it will just continue on with the rest of the cycles, but it's shut that high flow station, and then Scott would get an email in the morning saying station 12 high flow recorded, moved on to other stations, and okay, cool, I'll go out to that site, and then someone's vandalised the sprinkler and you've got water flowing out everywhere or something. If the other side of it is, it will find if you've got mainline breaks, the same thing. If it experiences a high flow on one valve, it'll move to the next valve. And then if it still experiences high flow, it moves to the next one, does another test. And if it's still experiencing high, it shuts all the valves down but leaves the master valve on. And then it goes, well, why are we still seeing flow? Because obviously all the valves should be closed, which means your main line's blown. So then it will shut your master valve down, shuts the whole system down, and then you would get, at that point, you might get a different alarm, and you can set that up to sort of say, if that happens, I need to know. Yeah, pretty much. Like that's a call out. Like I'm now getting up and dealing with this because I've got water pouring down the road or something like that. So yeah, you can adjust it and set it up differently to how you want. All right, so when we do diagnostics, a lot of the times you guys would find, I guess, coils that don't turn on the field, and controllers can tend to sometimes give ERR station, like #2 or open, or like depending on the controller, they'll give different sort of feedback on those controllers. When a solenoid valve doesn't turn on, what's happening there is there's a couple of different things that can happen when it doesn't turn on. If the controller's telling you, it's because it's something electrically is happening, because it can't know what's happening from a water standpoint. So what we tend to do, and I don't know if you guys run multimeters at all.
Got one.
Yep.
None of us know how to use it.
Yeah, that's all good. This can be done at the controller as well, which is when I used to do diagnostics for all sites, you would, instead of going out to the field and dealing with what's going on, I would know straight away from the controller how to find a fault in a controller. Now, what we have is, so feel free to grab these. I'll show you how we do this. So what we can do, grab another one for you. Just one more. Yep. No worries. You'll see on the dial, down the bottom left in the green area, there's that omega symbol. If we go down to that and to the 200 of that, which is effectively your dial pointing all the way to the bottom. Okay. If we go across a coil, and you'll see this now on mine, and you can test it on the valve yourself, but if we go across the coil, now again, this is AC, it doesn't matter which way we go. Even though these are black and red, it doesn't matter on the valve. And we're getting a number now of 25-ish, 24 and a half. That tells me anywhere from, I would say 18 to 60 in a number, I guess a reading of that sort of description. That's our ohms of resistance that we're seeing. That tells me that the coil's good. I'd hope so. It's a brand new coil, but it's a good coil. Now, what would happen if I went like, and this would be, I don't have a broken coil, but we would see, you see that OL, overload, excess, like there's a number, something, depending on the multimeter, how they report it, you get a different report. What that tells me is inside this, that's bridged. Like there's an actual, like it's closed off, like which means that's burnt out and it's all melted together or something's happened inside there. And so we would know straight away that that coil's done. If we see something like, we go across that and we get 7, like real low numbers, what that's telling me is I've actually got a potential crossed like join. So someone's done, you know, when we were talking about earlier where we're twitching wires together in a valve box, there's potentially these wires just resting against, like the two colours, like the different colours are actually touching each other, and so there's an actual potential bridge there. So we're knowing that there's something's going on. The reason I say this is when we go across to a controller, for example on here, let's say that someone said it was coming up on the controller, ERR #1, station 1's got a problem on it. I go across with my ohms of resistance test and I get against the C and the 1. This doesn't need to be on because we know that all the wires are still there anyway. So we're doing the exact same test I've just done. So we go across here and I would get, if this was wired up across C and 1, I would get that 24.6 ohms because I'm connected straight to that coil. And so, which tells me, okay, the coil's good. So there's another reason why that valve's not coming on. Does that make sense? Yeah. If I went across to here and went across to C and 1 and my multimeter came up as 1 or overload or excessive, that tells me the coil's done. Now, 90% chance that if that did that, and this is how it happens when I've gone out and done diagnostics on the field, I go across C and 1, overload. I know if I knew what the valve was that's out in the field, like it was Hunter valves, the first thing I would do is go straight to my ute and grab some wire joiners and my tools and a spare coil. And I would turn the valve, this off, take my coil out, put a new coil on. Before I do that, I check my coil is good, so I'm not installing a dead coil. Check the coil's good, yep, got numbers connected up. 90% chance away your system goes again. Because coils fail, I'm assuming you've done plenty of faulty coils out there, so yeah. That's the easiest way about you haven't touched wire joiners at that point, you haven't done anything in regards to in the valve boxes itself. You're literally at the controller and that station hasn't been turning on and you'll know because it's, it's dead or dry out there or whatever. You just go straight up with a multimeter to those across the common and the station that's in question. And normally you can go to another station and say, well, 3's working, what's that giving me? And you go, oh yeah, 35, cool. 2, 35, cool. 1, overload. Okay, 1's got the issue. And you know straight away, 1's got a faulty coil there and you can go straight out there and fix it up.
Sorry, I missed what you were putting the multimeter on.
Yep, that's cool. So you would take it all the way to the bottom,
so the 200.
where you've got 200 and you're looking for ohms, which is that Omega system. Cool. Yep, all right. So yeah, what I'll do there, if you do that on a coil now, with your Omega system, you can go across any one of those. There's no electrical current there, we're only testing for resistance. And I think honestly, from a fault finding point of view, it's one of the most easiest, like, it was actually great for when I was doing call outs because I'd literally go to someone's backyard and I knew it was going to be that or a Rainbird valve, and you'd go up to it and go overload, cool, valve, and I'd say, oh, $50 for a coil plus my call out fee, and I'm out of there in 15 minutes, and it was great. Like, it was an easy fix. until it wasn't, and it was always the day that it was raining or something. But yeah, so yeah, exactly, and that's where it becomes a whole like. And speaking of which, if you get, then it becomes a problem. If you're only getting, as I said, if you get really, really low numbers, it's telling you that there's a nick in the cable out in the field. That's where you need to probably have cable location diagnostic tools in the ground, where you can connect them to the wires that are in question, and it puts like a tracer voltage down that line, and then you walk around with a wand, and you know, like a cable locator guy's going along, and he's trying to find it, and it will tell you the power of the signal, and then all of a sudden you'll get to a point where that signal's worse, and it won't be in a valve box necessarily. It'll be somewhere where you maybe have a tree just snapping the cable a little bit or something like that. So you'll be able to actually find it. So, yeah. So yeah, you'll be able to test across there. No, I'm okay, thank you, mate. All good, thank you.
Have you got notes on this?
I do have I guess how to test. I've actually done a diagnostics like sheet that I've done for City of Playford, and I ended up emailing that to Lisa, and then Lisa just put that out to all of our guys just to have in the glove box of a car, and it's just handy to have because you might.
Yeah, but then when come summertime, we go, what was that?
Yeah, was it volts or ohms that I was going to or something? That's right. And what numbers are we looking for? Yeah.
Yeah, cool.
And so while we're talking about that, obviously when we're connecting to the controller, this one is powered. So now this one's powered, and this is like, pretend it's on a wall. Using our multimeter, we would go to the volts on the right hand side, which is the wave, and that's telling me it's an alternating current AC.
So the one on the left is if you want to do a battery or something.
100%, that'd be if you wanted to test a car battery or a 9-volt battery or a AA or something like that, because it's a DC valve.
Yeah.
Yep, so then obviously, and we know we don't want to be looking at 200 million.
No.
So we would go to that 20. Yeah, because obviously a car's going to give you anywhere from 15 to 8 volt, depending on where it's at in its charge. Right. And so that's the same sort of situation. You would be able to use this and go straight across to number 20. And again, when it's DC, now that we're talking DC, in a node or something like that, polarity is different. So you have a positive, like a car, you have a positive and a negative. So you need to make sure that you have your black in the common and your red in the VMA port there. And I normally, to be honest with you, because I'm not an electrician, I don't test these things on 240 volt. Yeah. You can, but I don't want to go. I just don't feel comfortable going up to a PowerPoint with these. So you would be able to test 240 coming into controllers and stuff as well. So for this exercise, we're going to be using the VAC, which is that V with the wave. Obviously, we don't need a C750 in high volt. We want to just see that 200, which is our standard residential style or lower. Now, on the controller, sometimes the other side of things is the controller's dead. It's giving me nothing at the screen. I don't know why, because the PowerPoint's on. Or first check the PowerPoint's on, but the PowerPoint's on and it's all good. What I then do is I go, okay, the PowerPoint's on, but am I actually getting power? So I normally have a phone charger or something that's there, and I just test that PowerPoint's good to go, because again, these things are 15 bucks each. I question how much they can save me if I was to put that into a light socket. So I prefer to just plug something into the PowerPoint and do a test. If that's still giving you 240 volt and you're getting power to the thing, we know the PowerPoint's good to go. Now we want to test that we're getting power into the controller. All right, so what we then do is you'll see on all controllers, you've got cables coming out of your controller on here. Okay, and you'll see on your left-hand side you've got 24 VAC, so it's 24 volts AC current, and we're seeing on here. Now that power is coming from the 240 volt and going into a transformer behind here, and the reason that's been locked away is obviously because accessing that is an electrician only situation. However, the ports on the top, however, because they're accessible like they are, is extra low voltage. It's 24 volt. That's what your valves are getting delivered to. So what we want to do there is we've got it set at 24 volts AC current, and we go across, and again, because it's AC, it doesn't matter which polarity. We go across and we're getting volt. So we're seeing, okay, I'm getting 24.8, 24.7 volts. Okay, that tells me the transformer's good. I'm getting power to that. The transformer's delivering the power that should be to that controller. Are the connections okay? Yep, they're okay as well, but I've still got no power. That controller's dead. That means that controller, something's fried in the board. Try a reset, it might flash it, but it's likely that it's either a warranty or it's a new controller depending on its age. If you go across here and we get 0 or 2 or 3 volts, well, hang on, that's supposed to be, and it's pretty clear because it's telling us 24. Well, we're not getting that. That means that's probably fried. Now, depending on the controllers, you can buy a 24 volt transformer. Most of the time, it's part of the controller. So if the transformer's faulty, then the controller in essence is faulty. So you would, the manufacturer would just give you a whole controller 90% of the time, if that makes sense.
To be honest, we haven't had a lot of issues with power.
Yeah, which means your power's probably clean then, so you're not getting big spikes and voltages coming through. Are you getting issues with down to the valves, lack of volts down to the valves? No, cool. So if you, just to give you a quick test on that as well, if we were to turn a station on, let's say we want to give station 1 a runtime. That's delivering volts down to station 1 now. With using the same volts, I'm going to go across 1 and common. Am I doing this right? I reckon I've just found a faulty controller. Like, legitimately found a faulty controller.
Well, that's one issue we might have. If we send that one out in the field.
Definitely.
That's the older version too, isn't it?
Yep.
Controller.
How's that for a training session? Just found a faulty. I won't sell you this one. Yep, so I'm getting volts to there. But you can see I should have, what I see there, I should actually now, because station 2's on, I should be getting the same. I'm not getting anything. Now that's telling me something's happening.
Station 2's fried.
Well, station 1's not working, station 2's not working, so I'm actually getting no volts on that controller, so that's actually giving me a fault on that controller. Now, if it was giving me a voltage, and we're like, yep, we're happy with that, I'll go, okay, cool, I know the controller's got power, it's doing everything it should be, I'm okay with all of that. And then we go out to the valve box and we would say, well, but why, if I open up those wires coming from the field, and I did, you know, you had green on one and the white on yellow, so I went across to green and white in the valve box, I'm getting 6 volts. But I had 24 here. Why is that? There's multiple things that can be that, but 90% of the time, it's going to be that you've got a nick in the wire. So voltage leak is happening and you're losing voltage. And it can you'll tend to find that happens when it's wet, because obviously there's moisture there and it's taking that away. It can also be that you have gone too far with the cable as well. So you've got too much voltage drop on the cable. We're using a 1/2 mil cable here for jobs. Commercial standards, I tend to stick with 1 mil because we can go up to about 180 metres with that. And then beyond that we go 1.5, and we put bigger size commons in where we can go 0.5 kilometre and all this sort of stuff. So, and the reason we do that is because we're going, these 0.5 mil is probably good for about 100 metres. Now, that doesn't work for a football oval. Well, we've got to get all the way around the other side. So to do that and achieve that, we have to put a fatter cable in. So we go to 1 mil, 1.5 mil to be able to get around there. When I've seen jobs that have been, I guess, aggressively priced to win a job, they go, oh, we haven't got voltage, or the solenoid was okay in the first 6 months because it's a brand new solenoid, but 2 years, a year later, that coil's had work now. It needs all that voltage to kind of get going because it's worn in a bit more. Now it doesn't work, and we'll go, well, hang on, you're only getting 12 volts down there when you should get 24. You've got too small a cable. Someone's cut corners on you, and it happens a little bit with the contractor side of things. If they've not had this understanding and they think irrigation cable is cable, it doesn't matter. It does matter. But if there's any of a question in regards to that sort of stuff, obviously give us a call. We'll on the spot help you out and do some tests over the phone. That being said, in that sheet that I'll give you to print off and distribute out, I'll send it to you, goes through all of how to do those tests as well. All right. Does that make sense as far as just doing some quick multimeter diagnostics on stuff? There's not much more from a diagnostics with the multimeter to test for valves. From an electrical standpoint, there's not much more we can really do at a basic 24 volt controller. Do we have volts or not? Yes or no? And what's our ohms like? If our ohms are good, then the coil's okay, so something else is happening. Go back, check your wire joins, cut them off, redo them, make sure they're all good again. Before I do them, twitch them, because you're not going to leave them like that, but just twitch them so you know the copper's touching each other. Get someone to turn the controller on. Okay, now it works. Okay, cool, I know it was a wire join then now, so then I can cut that cable, do a new wire join, test again, we're good to go. All right, cool.